Hello everybody. In this video we are going to learn about magma composition. So these are the two lesson goals for this video, and let's move on to four categories of magma. So one thing that I would like to remind you is that as magma rises through the lithosphere, the original chemistry of the magma can actually be significantly altered before it reaches the surface. Now, because of that, magma can actually occur in a range of composition from felsic, intermediate, mafic, and ultramafic. So those are the four categories of magma based on its chemical composition. Okay, so I would like to just mention that felsic has the highest amount of silica, whereas ultramafic would have the least amount of silica in it. Okay, so felsic magma has a lot of silica, ultramafic magma has the least amount of silica. Another process that I would like to introduce here is called magma differentiation. So this process refers to any type of process that could alter the composition of magma. Okay, that could alter the composition of magma and eventually the composition of rocks as well. So there are five different ways that I have listed here, and these five ways they can actually produce magma variation. So for example, I have different source rock, partial melting, assimilation, magma mixing, and the last one is fractional crystallization. So let's talk about the first one first. It is called different source rock. I mean, this concept, I think it should be pretty straightforward. If you have two different rocks that melt, then the melt or the magma generated from those two different rocks will be completely different, right? So for example, if I have mafic rocks like basalt, for example, that are melted, then the melts will be simply mafic magma, right? In composition. And if compare that with if I have a felsic rock such as granite, for example, that melts, then the magma that are generated from that would also be felsic in composition. Okay, so as simple as that. If you have two different rock types, then the melt will also have two different compositions. The second one is called partial melting, and this is something that we're going to talk about a little bit more. But before that, let's recall one of the process that can generate magma, and it is called a heat transfer melting. Okay, and as we remember, that heat transfer melting happens here at the shallow part of the earth, at the base of the crust, and the melting was caused by the heat transfer from this hot magma towards the crustal rocks here. Okay, and I mentioned that these crustal rocks will start to melt and create this new magma chamber, maybe. But my point here is that the process of melting these crustal rocks is actually not very straightforward. Okay, what I mean by straightforward is that imagine if you have a ice cube, and at atmospheric pressure, that ice cube will start to melt at a temperature above 0 degrees Celsius, right? So, for example, if you have zero point 0.5 degrees Celsius, then this should be enough to melt the ice, even though it may take longer, but it will eventually melt the ice. Okay? It turns out that melting rocks is actually not that straightforward. Okay? The reason for that is because rocks typically have multiple types of minerals in it. Okay, and those different minerals will have a different melting temperature. Therefore, rocks will not melt all at once. What it's gonna do is that it's going to melt partially. Okay, slowly and partially, because all of these minerals will have different melting temperature. So, for example, here originally I have rocks that again consists of multiple minerals, And if I start to increase the temperature, these rocks will start to melt. Okay, but the very first thing that melts are the silica rich minerals such as quartz, for example. Okay, so quartz will start to melt at a lower temperature, and then eventually it may be followed by iron rich minerals such as olivine, for example. Okay, olivine is rich in iron, and it will start to melt after quartz. And eventually, if you keep increasing the temperature this way, then eventually you would create almost, the rocks will almost entirely be melted. Okay, maybe a little bit of, chunks of minerals here and there, but the point here is that almost all of the rocks will melt. Okay, so that is what we call as partial melting, that the different minerals within the rocks will start to melt at different temperatures. Okay, different melting temperatures. The next one is called magma assimilation. This should be pretty straightforward as well. If you have a magma chamber here, because of the heat from the magma chamber, it would start to eat up the wall of the magma chamber. Okay, so the magma can invade the cracks and break off rocks from the magma chamber wall. Okay, and most of the rocks that fall into the magma chamber, most of them got melted basically, but few are preserved. Now that's the interesting part. When it's preserved, this is what we call as xenolith. Okay, so xenolith are fragments of older existing rocks that are ripped up by ascending magma. So remember that when magma rises towards the surface, it actually traverses much of the materials during its ascent. Okay, and the next process is called magma mixing. Magma mixing happens when you have two different magma chambers with different compositions somehow connects at depth. Okay, so for example, here on the right, I have mafic magma here, and then on the left here, I have felsic magma, and somehow these two magma chambers, they are connected right there in the middle. Okay, so as a result, the magma will start to mix, and it may generate new magma that have totally different composition than the original two magma chambers right here. Okay, so in this case, I put intermediate as the resulting, as the as the the result of the mixing of these two magma chambers. And the last process is called fractional crystallization. Okay, so again, I want you to think about crystallization of water. It freezes at temperature of 0 degrees Celsius. Okay, and it will start to become ice at 0 degrees Celsius. But magma, again, it is not that straightforward because the different minerals will start to crystallize at different crystallization temperature. And that is the reason why I said magma crystallizes in a more complex manner than ice, because of that fact, because minerals have different crystallization temperatures. So for example, here I have iron-rich minerals such as olivine that freezes and solidifies at higher temperature. So the very first minerals that solidify will be olivine. Okay? And then followed by silica-rich minerals such as amphibole or quartz. So if you think about it, this would be the opposite process of partial melting, right? For partial melting, we have solid rocks that will melt, that melts. Here in this case, in fractional crystallization, we have melts that solidifies. Okay, so this will be the opposite process of partial melting. So again, just to give you an example, here is the original melt with mafic composition, for example. And then if we decrease the temperature at time 2 right here, then we would start to generate some olivine or maybe some plagioclase in it as well. Okay, so the olivine will start to melt. I'm sorry, the olivines will start to solidify and crystallize, and then after that, if we keep decreasing the temperature of the magma, then other minerals will start to form. For example, maybe amphibole will start to form. Okay, now at time two, we may have, because we have a lot of olivines that will start to form, then it will change the chemistry of the magma. So here maybe we have mafic, and the second time here we would get intermediate, and then once we have a lot more minerals that crystallize, then the chemistry of the magma will also start to change and would become more and more felsic. Okay. Now that discussion leads to our discussions of Bowen's reaction series, and I just want to give you a heads up. I'm not going to talk about it in this section, but we will talk about this in the next section. But it is a series of chemical reactions that take place in silicate magmas as they cool, and this is the person who basically did the experiments on that. He did the important experiments that help us understand the evolution of magmas. So that leads to the next questions that I'd like you to answer. The first one is, what is the basis of magma classification? Question number 5, which is not part of the magma differentiation processes? Question number 6. Because of partial melting, the composition of the first formed melt will be what? Alright, everyone. So I think that'll be it for this video, and I will see you again in the next one. Bye bye now.